It is Wednesday, February 19th, and today is a remote learning day. So I'm quickly going to go through things that you need to know, things you need to remember. We do start Unit 3 today. It is probably our most important unit of Math 3. I have tutoring on Thursday this week. Today would be a great day for the 7 people who have not done their Neptune Navigate to get that done before February 28th. Your Unit 2 test is graded and in PowerSchool. You'll take a peek at it tomorrow. We do have a Unit 3 quiz either this Friday or Monday. We're going to be a little bit flexible with that, but our Unit 3 test right now, we actually moved it to March 4th with all the weather stuff. And then your optional Unit 3 Delta Math assignment, that's due on, now it's due on a Monday on March 3rd. All right, here's our learning goal for today. You're going to be able to add, subtract, and multiply polynomials. That is a skill that you already have. You're also going to be able to identify the number of terms and the degree of a polynomial in order to classify polynomials, and that might be new to you, but that's our job today. Sorry, let's go back to that. So this is a polynomial. It has terms, it has variables, it has coefficients. When we're looking at a polynomial, there is a certain order. It's called standard form that we write polynomials in, and that's what we're going to talk about. So first of all, a monomial is an expression with only one term, so it's a single term. A polynomial is an expression with 2 or more terms. So we mostly look at polynomials. Terms are coefficients, those numbers out in front of the variables. So the 3 is a coefficient, the variable is the letter, and possibly constants that are separated by adding or subtracting signs. So if you're counting the number of terms in a polynomial, you look for the separation of the addition and subtraction signs. So for example, 5x plus 2, that has 2 terms. Just x, that has 1 term. 4x cubed minus 3x plus 1, that has 3 terms. So 1, 2, 3, separated by addition or subtraction. 9y squared minus 6y, that has 2 terms. And then be careful with this last one, it's a little tricky. It has not been, we have not combined like terms. So 2x cubed plus 7x squared plus x squared. Before we can count the number of terms in a polynomial, we have to make sure that it's as simplified as it can be. So we would rewrite this as 2x cubed plus 8x squared minus x plus 8, and in fact it has 4 terms. All right. When we're naming polynomials, we give an expression a name by its first name. So kind of like us, we have a first name and a last name. That's how polynomials are also named, first name and last name. So the first name is based on the degree. The degree means the highest exponent. So when we're looking at a polynomial, we're looking for the highest exponent. That's the degree of the polynomial. So if you have a degree 0 polynomial, that is called a constant. An example of a constant would just be 7. And I'm just giving you examples of leading terms. I'm not giving you examples of full polynomials. I'm just giving you an example of the leading terms. If you have a linear, if you have a linear or 1 degree polynomial, he's called linear. And these, you worked a lot with these in your early math days. We don't see them as much anymore. Something like 2x. That has a degree of 1 for the exponent. It's called linear. Now quadratics, you're very familiar with. Quadratic is a second degree polynomial. And it might look like 5x squared. Anytime we see that squared as our leading coefficient or leading term, it's a quadratic. If we have a third degree polynomial, he's called cubic, and you have seen some of those. A cubic could look like this, 4x cubed. And we don't necessarily have to have the coefficient on that variable. Um, so a fourth term polynomial is called a quartic. So like there are 4 quarts in a gallon, there are 4 quarters in the year. Quartic is a 4 exponent to the power of 4, or a 4th degree polynomial. If we have a 5th degree polynomial, he's called quintic, and we don't see that very often. So maybe like 7x to the 5th power. And then you can have polynomials that are 6th degree or higher. We call those nth degree polynomials. Whatever the number is, that's the degree. So for example, if I have 10 times x to the 9th power, that would be a 9th term polynomial. I'm sorry, not 9th term, 9th degree polynomial. Now, when you get to your practice and when you get to your Delta Math homework, you're going to see things like this. I'm going to put a little asterisk over here. You have something like 7 times y to the 3rd, z to the 4th. And this is one term. So this whole thing is one term. So when we're looking for the degree of the polynomial, we actually add those exponents. So this would be considered a 7th degree polynomial. And not because of that 7 is the coefficient, but because 3 plus 4 is 7. All right, the last name for polynomials. Our last names are based on the number of terms in the polynomial. So if we have one term, it's called a monomial, or his last name is monomial. An example of that would just be 3x. It could be 3x cubed, but that's a monomial. He's all by himself. If there are 2 terms, he's called a binomial. A binomial could look like 2x minus 1. If we have a 3-term polynomial, his last name is trinomial. Trinomial. So something like 2x squared plus 4x minus 3. And if we have our 4th term polynomial, a 4-term polynomial, 4 or more, we just call him a polynomial. So for example, 6x cubed plus 5x squared minus 3x plus 2. All right, so that's how we name them. And then just as this is an absolute thing that we have to do, an expression should always be written in standard form, and you aren't necessarily going to always see them in standard form. If it's not in standard form, you need to change the order so it is in standard form. This is like an always and forever. That just means the highest exponent to the lowest exponent constant is always last. So let's go ahead and look at some examples. We're going to combine the knowledge that you have with adding, subtracting, and multiplying polynomials and this new thing of naming your polynomial. So if I have something like 2 binomials that I'm adding, x plus 2 plus x minus 5, that's really x plus 2 plus x minus 5. I can just take those parentheses off and combine like terms. I've got x plus x, that's 2x. I have 2 minus 5, that's negative 3. And that's what the polynomial would look like. So they wanted me to simplify, and now they want me to classify the polynomial. So we have to give it a first name and a last name. This is a 1st degree. He's x to the 1st power. So he's a 1st degree polynomial. So we call him linear as his first name. And he's 2 terms, so he's a linear binomial. All right, if I have something like 2x squared plus 4 minus x minus 1, you have to remember that that minus applies to everything behind it, everything in parentheses. In effect, it's changing the sign of everything in parentheses. So I am going to rewrite this one, 2x squared plus 4, and that's minus x plus 1. So you have to be careful with those because those are the ones that will mess you up. Once I'm done with that, I'm going to go ahead and simplify. I have 2x squared minus x plus 5. So I want to make sure that it's in order from greatest degree to a constant, and then I can classify it. So this one has a degree of 2. If I have a degree of 2, it's always a quadratic. So this is a quadratic, and then it has 3 terms, trinomial. So quadratic trinomial. If I am multiplying, like here I'm multiplying a monomial by a trinomial, I have to make sure that I multiply everything out. So I have 4x times x cubed is 4x to the 4th power. So again, we're using those exponent rules that we refreshed on in Unit 2. 4x times 2x squared is going to be plus 8x cubed, and 4x plus 5 is going to be plus 20x. So until we get it in its most simplified form, we can't name it. Nothing to combine here, so he's done. And then I'm going to name it. It's a fourth degree polynomial. That makes him quartic. And he has 3 terms, so he's a quartic trinomial. First name, last name. All right, if I have a binomial times a binomial, that's when we have to remember to multiply every term in the first binomial by every term in the second binomial. I like to use the arrows. So 2x cubed times 6x is 12x to the 4th. 2x cubed times 1 is just plus 2x cubed. And then I like to go down underneath. Negative 4 times 6x is negative 24x. And then negative 4 times 1 is negative 4. I don't have any like terms, so I'm done. And now I can name the polynomial. He's 4th degree, so he's quartic. And he has 4 terms, so he's a polynomial. All right, on the back side, we're going to use your knowledge of perimeter, volume, and area to do the same thing. So for finding perimeter, that just means adding up all the sides. So with these shapes, we're just going to find the perimeter and classify the polynomial. So keeping in mind when we find perimeter of a shape, we have to go all the way around this shape. So I'm going to show that because these are my notes and I want to make sure that they're clear. Then I'm going to just combine like terms, and I just like to look all the way around, or I can even look at 2x squared plus 5x squared and then double that. So that'd be 7x squared. If I double that, that's 14x squared. And then I have 6x and x, that's 7x. If I double 7x, it's 14x. So that's the perimeter. And now I need to classify the polynomial. So he's a 2nd degree. That makes him a quadratic. And he's a binomial because he has 2 terms. This example would be exactly the same. If it's okay with you, I'm not going to rewrite everything. I'm just going to double what I see. Just make sure if that's a strategy you're going to use that you remember to double. I've got 10x cubed plus 3x cubed. That's 13x cubed. But if I double that, I've got 26x cubed. And then 4x, if I double 4x, I get 8x. And if I double 2, I get 4. So making sure that you're doing the perimeter around the entire shape, not just the 2 sides. So there's my cubic trinomial. So he's cubic because he's a 3rd degree polynomial. He's a trinomial because he has 3 terms. All right, we're also going to use your knowledge of finding the area of shapes to find the area and classify the shape. So the formula for finding the area of a rectangle square, area equals length times width. So we're going to be multiplying The formula for area of a triangle, you do the exact, personally, I do the exact same thing, but I just cut it in half. So area equals, I guess we call it base times height. But I don't like to multiply by 1/2. I like to just divide by 2. But whatever way you're used to doing area is perfect. So find the area of the shapes, classify the polynomial. So if I'm going to find the area of 6x cubed plus 4x times 3x squared plus 1, I'm going to multiply 6x cubed times 3x squared. So I have 18x to the 5th. 6x cubed times 1 is 6x cubed. 4x times 3x squared is 12x cubed. And 4x plus 1 is plus 4x. I've got these middle terms that I need to combine before I'm done. So I still have 18x to the 5th. 6x cubed plus 12x cubed is 18x cubed. And 4x on the end is just 4x. So that is the area of this shape. And now I need to classify the polynomial as well. So it's a 5th term, that's quintic. And it's a trinomial because it has 3 terms. All right, and then finding the area of a triangle where we're going to multiply, sorry, I'm going to take my area is 2y plus, actually, I'm going to rewrite that. I like my y up front. I'm going to say y times 2y plus 6, and I'm going to cut that in half. So first thing I need to do is multiply the area equals 2y times y, or 2y squared, y times 6 plus 6y, and I'm going to be dividing all that by 2. I do have to simplify. If I can simplify, I have to simplify. So the area of that triangle is, I'm going to take 2y squared divided by 2. I get y squared. I'm going to take 6y divided by 2, and I get plus 3y. Once it's fully simplified, then I can classify it. It's squared, so it's a quadratic. And it's 2 terms, so it's a binomial. A quadratic binomial. All right. The length of a rectangle is 1 less than twice the width. Write a simplified expression that represents the area of the triangle and classify the polynomial. So they did not give me a picture. I'm going to draw a picture. And we know we need length and width. So area equals length times width. I know the length is 1 less than twice the width. So I'm going to take twice the width, and I'm going to take 1 less than that. That looks like that. I don't know what the width is, but I'm basing my length on the width. So width is just width. And then I'm going to go ahead and multiply. So my area equals W, my width, times 2W minus 1. My area equals 2W squared minus W. And now that it's fully simplified, I can classify it. It's a quadratic binomial. Quadratic because it's to the 2nd power. Binomial because it has 2 terms. All right, and the last couple examples will do have to do with volume. Volume is length times width times height. So if I'm finding the volume of shape, it's length times width times height. So we're going to go ahead and find the volume of the shape and classify the polynomial. So if I have my length, or my volume is length times width times height, I know it doesn't matter which one I choose for length or width or height. I've got 4x squared times x squared times x cubed. The way that I like to deal with these, the best way to deal with this is just take a pair and multiply. Take that answer and multiply it by the next one. So volume is 4x squared times x squared is 4x to the 4th. I still need to multiply that times x to the third. So the volume is 4x to the seventh. And again, you do have to be solid on your exponent rules. That's the volume of that shape. When I classify that, because it's a 7, that's past quintic, so that's a 7th degree. And because he only has one term, he's a monomial. So 7th degree monomial. All right, if I'm finding the volume of this rectangular prism, the volume is equal to 2x to the fourth times y times 7xy times 5xy. So again, I'm going to take these first two, multiply them, and then multiply that answer by the last term. So my volume is 2 times 7 is 14. X to the fourth times x is x to the fifth. Y to the first times y to the first is y squared. And I still need to multiply that by 5xy. My volume is 14 times 5 is 70. X to the fifth times x is x to the sixth. Y squared times y is y cubed. And that is my final answer for the volume. And just as a reminder, this is one term, so it's a monomial, but I have to add that 6 and 3. Because it's a complete term, I'm going to add the exponents. This is a 9th degree monomial. Okay, we've got one last example. The length of a rectangular pool is 3 times the width. The height of the pool is 4 feet longer than the width. Write a simplified expression that represents the volume of the pool and classify the polynomial. I do not draw 3D shapes very well, so I'm just going to list my length, my width, and my height. So the length is 3 times the width. The height is 4 feet longer than the width, so it's the width plus 4. And then the width again is just everything we're basing the length and height on is the width, so we're going to use that. So we're going to multiply these. To find my volume, I'm going to take 3w times w plus 4. So I'm going to multiply these first two first. 3w times w is 3w squared times w plus 4. So my volume is equal to 3w cubed plus 12w squared. The degree of the leading term is 3, so that is a cubic, and it has two terms, so cubic binomial. Okay, now that your notes are done, you are going to get out a lined piece of paper. You're going to go ahead and give this a try with your operations with polynomials practice quizzes. You're going to be submitting that today, and then you also have homework for this concept. So 2 assignments, there's a quizzes. You will be turning in a picture of your work, and then the homework for today is also posted. I hope you have a great day. Please stay safe, and I hope to see you tomorrow. Talk to you soon.